What's up, Maddie?
Can you check my proof from the other day? Because I got a different answer than what was on the thing.
Should I go around to all the 28 kids and check theirs too? Or just you? Can I do it at the end of class?
Yeah.
Is that okay? Okay. We ready to go? All right, let's start talking about topics we haven't got to yet. So let's start with number 7. There's a trap here on number 7 I want to make sure we don't fall into. Some of you are going to be like, why is he reviewing this? This is so easy. Good. I'm glad you think that. But some of you might fall into the trap, and that's why I'm going over it. We are told that AE is congruent to DE. Let's throw some hash marks on that. All right, which statement is always true? What did I just create by putting the hash marks up there? Ooh, an isosceles triangle. Yes. What triangle is isosceles? EAD. So we have a theorem that we put in the reasons column of a proof that says in a triangle, congruent angles are across from congruent sides. I want to make sure you know where those congruent angles are here. It's got to be in the same triangle as the congruent sides. The angles and the sides must be contained in the same triangle. So which angles are you going to mark congruent up here? Angle, use a single letter here for me. Angle A and angle D. Yes, that is the correct answer. I'm going over this because I don't want you to think this. Oh, look across from. So it's got to be those two. And conveniently, that's choice 3. Pick me across from, because I don't understand the theorem that well. Everyone good on how we apply it? The angles and the sides all have to come from the same triangle. We good? Now I know some of you are like, yeah, great. But some of you might have picked those angles. All right, next one. We have yet to discuss anything about parallel lines. And this is a parallel line and quadrilateral one, all in one. Oh, boy, are we lucky. All right, what makes ABCD a parallelogram? What's good enough to make ABCD a parallelogram? All right, 1 congruent to 3. Everyone look at those angles, 1 and 3. What do I call those angles from our parallel lines unit? Those are corresponding. Good. Now can you take it next level for me and tell me which lines are parallel now? If 1 and 3 are congruent, that makes these 2 lines parallel. And if you're having trouble, I always like to highlight the angles. 1, 3, and then to me it makes it pretty easy which are the parallel ones, right? So it would be what? Lines MN, N, right? Is that good enough just to say that's a parallelogram if I just have that? No, I don't need one pair. I need both pairs. So that's not going to cut it. Next, 4 congruent to 7. 4 and 7. What type of angles are those? More review. Alternate interior, which would make what lines parallel up there? L and K. Good. Is that good enough? No, still same issue I had with choice 1. Only one pair. All right, keep trucking. Let's go to number 3. What if I had 2 and 5 alternate interior with 5 and 7 corresponding? All right, let's start here. 2 and 5 give me what parallel lines? K and L. 5 and 7 give me M and N. Good enough? Now I have opposite sides parallel. That makes it into a parallelogram. I do want to challenge you because we are in honors. Why wouldn't 4 work? Ooh, something up there doesn't seem right with 4. Why wouldn't 4 work? Look at those angles. Nick?
3 and 4 are vertical angles, and they don't need, the last one needs to be parallel.
Correct. Vertical angles never imply parallel lines. Okay, so again, you'd only have 1 pair, not 2. All good. Okay, we are moving on to problem number 16, everybody. 16. Back in the day, this problem would have been cake, but now it's June and we forget everything. So, which pairs cannot be proven congruent? Which pair cannot be proven congruent? All right, hey, this is the real reason why I'm doing it, so we can review the 5 ways to prove triangles congruent. What do you got for me? Good start, good start. Side, angle, side. Make sure the angle's in between. Side, 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 right? All 3 sides congruent. Excuse me? All right, I was going to say you better throw some S on the end of that. Angle, great. What do we got?
Angle side.
Yeah, what if the side's in between? I got that. And always the forgotten one. Whoa, look at you guys. But only for right triangles only. All right, let's go through each of these. Give me a yes or a no if it's a yes. Why? Before we go, though, remember, you are allowed to mark your own reflexive sides and your own vertical angles. You do not need to be given that info, that it's reflexive and vertical. Right? You can mark them on your own. I tell you that because when we start with number 1, isn't BC reflexive? Are the triangles congruent?
Yes.
Better watch your mouth here. Both classes have said something wrong. By what method? Yeah, not HL. Right triangles don't mean HL automatically. What's the H and HL stand for? And that's AB and BD. I know nothing about them, so it can't be HL. That's side angle side. Good. All right, number 2, I can mark vertical angles and congruent or not. Congruent by? Ooh, which one? Is the side in between? Cover one up. Is that side in between the 2 angles? Nope, so it's got to be angle side. 3, I can mark JL reflexive. Get out of here if you don't know this one. Side. What's the, okay, process of elimination, it's going to be 4, but what's the problem? Those angles, not in between. And darn it, I'm going to snap. All right? It's not showing up, nor will it ever in your lifetime. Okay? Don't put it down. It's not a way to prove triangles congruent. Because if I have a teacher when we're grading say, whose student is this that put side angle? It's one of mine. I'm just going to totally deny it. Like, never heard of that student before. It must be somebody else, another teacher's. Okay. We good here? All right, keep going. We've got a couple other things here. 19. We reviewed some facts with Petro's homework question. We got to review another circle fact here now. And not only that, I think it's probably a good idea to draw ourselves a little diagram here to see what we're working with. Circle O. What's that telling me? Center is O. And I draw a diameter in that is ROQ. So diameter R to O to Q. And it looks like we're not going to stop at Q. We're going to keep continuing outside to a point called P. That's awful. Not any better, but. And then tangent PA is drawn. Tangent? I must have said it in Spanish. Tangent? Hits the circle in one spot. We're not talking about SOHCAHTOA tangent. So it's going to hit the circle at point. You can keep it going if you want, but it's going to hit the circle at point A. All right, we're told that arc RA measures 100 degrees. What's angle P? All right, it's a fact. One of the, I know numerous circle facts that we're going to have to know. I get it. You got 2 weeks to get it together. You got 2 weeks along with your other regions. I get it. All right, simple question. Where's angle P? Inside or outside? Okay, our discussion's over then. If you are asked to find an angle that is completely, not a tweener, completely outside the angle, it's a half of 2 arcs being added or subtracted. Subtracted. If it was clearly inside, it would be added. All right, the one inside is added. All right, what 2 arcs? The 2 arcs in between the angle. One of them is already 100, and maybe this is why this region is tricky. I have no idea about the other one. QA. But ROQ is a diameter, which cuts it into 2 semicircles measuring 180 apiece. That's 100, so that must have been 80 degrees. And again, you want to talk about traps. You just remember you subtract and you totally forget to take the 1/2. What's 100 minus 80? Oh, there's the choice up there. Pick me, because you didn't know your rules and forgot to divide by 2. I don't know how you would get 40, or maybe you take half of, maybe you think it's an inscribed angle, so you take a half 100 or half 80. Woo! Nasty, kids. Nasty. They're going to come strong. Speaking of strong, 21. Whew. Buckle up for 21. Love it. Love 21. It tests you on so many different areas of geometry here. First of all, the diagram just looks intimidating. Some of you might start crying. There will be tissues available at the exam. EB, again, I will disown you if anybody starts crying during this exam. And also remember, once you hand that exam in, it's been real, it's been good, but it hasn't been real good. Our relationship, association, no more. No more out in public, don't know who you are next year in the hallways, no idea. Hopefully we were putting a right angle symbol there because they're perpendicular. Angle E is 62. Angle C, 51. Any siblings coming in next year? Yeah? Taking a BC? You made up for your sister last year, so it's all good. All right. Can only go up, so we're good. Everyone, we're all good here? Brother or sister?
Brother.
Brother? Would he have the guts to stand up and say, you're out?
No.
Yeah, no, not either. Go to the dartboard. I still wish he would have stood up and just stared either Zach or just right in the eye and said, see ya! Done. Slit the throat. God, that would have been a classic. It's all right. Which, by the way, can we talk about the remaining here? If there's 3 people out of you 6 that are left that get the high score, there's no reason to vote. Okay, so just throwing that out there. All right, if there's 4, I got to do something about it. I don't know what I'm going to do if 4 out of 6 get the high score, but we'll figure something out. All right, but if 3 out of the 6 get the high score, sorry, and no vote needed. We're moving right to the finals. Prepare your speeches. And you think I'm joking? If you want to speak, if you're in the final 3 and you want to speak and plead your case, I'll give you a pass to come to my 7th period class and talk, and you can have the same speech 8th period. May make a difference. Who knows, right? May make a difference. Change somebody's mind. All right, here we go. Back to business. What is angle FHB? So you got to get me to that angle. There is a lot going on. You have 2 segments that are congruent, and they provide you that to use it. Don't overlook it. And also, don't overlook ABCDs of parallelograms. So let's know my properties. Anybody want to start us off by putting an angle, a new angle somewhere that you are confident in? We're not going to get right to the answer. Absolutely not. You're going to have to get there. Will? Oh, I thought you were.
I can do it.
Can you?
BF is 62 degrees.
BF, nice job. It's isosceles, isn't it? So across from those congruent sides or congruent angles, that's where I expect probably most of you to start. That is 62 as well down here. Yep, isosceles triangle. All right, keep getting me there. What else do I know now? A new angle. What other angles can I find up here? You'll notice I've kind of completely went away with the numbers. Nick? BFH, because it's adjacent. Those 2 are complementary. 62 and 18, right? So that's 18. Let's keep going.
It's 28.
Is it 28? Yeah, one job. This guy teaches honors, right? Yep. How? Who knows? All right. We haven't talked about ABCD being a parallelogram yet. Anybody find any other angles? Because that's a parallelogram. What's up, Claire?
EAD is 59 degrees.
EAD. Yep. Opposite angles in a parallelogram are congruent. That's a property. Great. We're filling in we'll get there eventually. We just got to keep filling in angles. Anything else you want to fill in? Dylan.
FBE is 56.
FBE is 56. Yep, because in a triangle, Dylan, I assume, is using triangle BEF. We already know 62 and 62. Subtract them from 180, we get 56. Good job, guys. Let's go. Any more? Ayushi, go ahead. ABC is 129. Good. That's another parallelogram fact. Consecutive angles. 2 adjacent angles are supplementary. So this is 129. Can you guys get the angle next to 56 then? What's the angle next to 56? 73, yep. And I think we're there. Because I see a triangle right now that's called triangle BHF. I already know 2 out of 3 angles. And the third one is the one they're asking for in the problem. So $1.80 minus 73 minus 28, 79 degrees. All right. Again, I'm not going to spend much time up here. You guys now go work. Let's go work. Again, you can work on anything you want in that pattern. You can work on the ones I just suggested at the beginning of class. You can work on any one you want. If you want to go dig into the parts 2, 3, and 4, your show, because you know where all the answers are. But definitely call me. I'm going to walk around, make sure you're staying on task, and if you have any questions, don't be bashful to ask. We got 2 weeks here. 2 weeks.